All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part 3 of our lecture on the topic of the Internet architecture. So we will jump to the point from where we left off, and we will start off by talking about Internet inter-AS routing. All right, so what is an AS? An AS stands for an autonomous system, which basically is just a group of networks which is maintained by a single entity. When I say a single entity, it could be a single company or a particular regional office of a much larger company, whatever it is. But it is a group of networks which are maintained by that single provider. And for the internet to work, there needs to be a form of routing to connect these group of networks as AS, which we call as AS, and to provide something that we call as inter-AS routing. So the most popular protocol to provide inter-AS routing is what we call the BGP, which is short for Border Gateway Protocol, and this is the primary interdomain routing protocol, which is based completely on autonomous systems, or ASS. So BGP protocols, what do they do? They allow AS subnets to advertise its existence to the rest of the internet. So whenever there is an existence of an autonomous system, it can advertise its existence to its neighboring autonomous systems so that it can provide route to other networks. The BGP protocol has two variants. eBGP, or external BGP. This is used or this is run between two separate or neighboring autonomous systems. On the other hand, there is the other version, which is iBGP, and this is short for internal BGP, and this is used to propagate the reachability information within a given autonomous systems. So there are routers, multiple routers, which are present within a single group of networks as a single autonomous system. So the routers inside the same AS would run IGP. On the other hand, the border routers, which connect an AS to another neighboring AS, would run eBGP. And the way that these routes are propagated would basically determine the way the network could route the overall packet into to the internet, and also defines the different policies based on financial agreements. So let's try to understand the basics of BGP. So a BGP session is something that we refer as where two BGP routers exchange a set of BGP messages. Generally, we say that they advertise paths to different destinations or network prefixes. So if you remember, we have network addresses and broadcast addresses and IP addresses for specific hosts. And we are representing a group of hosts together in a single network. We are referring to a network prefix, right? So the BGP exchange, the BGP protocol allows different routers running the BGP protocol to exchange messages based on the network prefixes. And also, this is something that we call a path vector protocol. The path vector protocol particularly implies that the BGP is a protocol which allows the definition of a complete path from the source to destination. So it's not a one-hop connectivity or reachability information. So for example, if there are three ASs, AS3, AS1, and AS2, the BGP message will say that AS3 can reach AS2 through AS1. So the whole path information is actually advertised using BGP. So AS3 advertises a prefix to AS1, which means that AS3 is a group of networks which has a certain prefix, and it will then advertise that I have the given prefix located within my autonomous system, and please advertise it forward. And it advertises this first to AS1. So AS3 basically is saying that it will forward any datagram and IP packet for that given particular prefix. And also it can aggregate prefixes in its advertisement, which implies that it is advertising a group of networks together with the help of BGP. So it's not advertising one network at a time, but rather aggregate multiple networks in its advertisement and then advertising it onward to AS1. So if we consider the same scenario, a similar scenario, we can say that, for example, router 3A right here in AS3 and router 1C, which is located in AS1. So these two routers are going to run the external BGP version. And the reason for this is because both of these routers are the border routers for the autonomous systems. So AS3 sends the prefix reachability information to AS1, and AS1 then can actually forward the information onwards to other ASs. However, inside AS1, the routers 1C uses iBGP, which is internal BGP, with the other routers in the same AS, which are 1A, 1B, and 1D. So all of these are AS internal routers, and whatever advertisement that 1C received from 3A, it is going to propagate or distribute the same information onwards onto all the others internal routers using iBGP. And eventually, when 1B gets to receive this information regarding AS3, 1B can then re-advertise this information to AS2, which runs eBGP between 1B and 2A. So whenever a router learns a new prefix, it basically creates a new entry for the prefix that it just learned and puts it in its forwarding table. And AS2 can now see that to be able to reach AS3, it needs to go from router 2A to 1B, and then whenever it is inside AS1, it can reach 1C in multiple ways, but when it reaches 1C, it can reach over to 3A, which is in AS3. So this whole route is stored in AS2's forwarding table. And the way that these advertisements work is dependent quite a bit on what we call our policies, and this is predominantly driven by the financial motive. So in this simple example, we say that A, B, and C are provider networks, which means that these are the large-scale ISPs which connect the small-scale access nets or smaller ISPs X, Y, and Z. So ABCs are provider networks where X, Y, and Z are customers of the provider network. We can also say that X is dual homed. This means that this is attached to two provider networks. However, even if X is dual homed, X does not want to route from B via X to C. So X is not interested to route this path. And therefore, it will just not advertise B to B that it has an existing route to C. So this connection is actually hidden from B. And the main reason for this is, again, the financial motive, that X does not have any motivation to route the packets that B would like to send to C, and X would like to take the hit for it to connect B to C through X, unless definitely B actually is paying X some money to be able to connect to C. So in terms of the way the advertisements work, so let's say A advertises a path AZ to B. So A is advertising a path AZ to B. So B now knows that if I want to reach Z, I need to send it to A. Next, B then advertises a path BAZ to X. So B is now telling X that if you would like to reach Z, you need to route it through B, A, and Z. So this is the path that X needs to use to be able to reach Z. So we can ask ourselves the question that should B advertise path BAZ to C? So this is a path that B has established. But does C need to know about this path? The thing is, if you notice that Z and C are not B's customers, so Z and C, neither of these are B's customers. So A, B, and C are all provider networks, and B's customer is only X. Z is a client to A, Y is a client to C. So Z and C are not B's customers, so therefore B gets no revenue for routing CBAZ. So if C would like to reach Z and C would like to send it this way, B does not have any motivation to route these packets. So therefore, B wants to route only to and from its customers, which in this case is X. So therefore, B wants to force C to use the route Z through A. Unless, of course, C is paying B some money to route this path. If there is no money, then B would not advertise the route CBAZ. All right. So we just covered how the internet can function by propagating this network information and the connective information, the reachability of autonomous systems. However, something that if you would like to relate to to the Internet Protocol chapter, the concept of IP addressing, and we know that IP addressing is divided into multiple classes, has a restricted number of bits, and has a particular process of generating the IP addresses. And however, one of the strict limitations that we have with IP addressing is the limited number of IP addresses that we can use and generate from the 32 bits of IPv4 addresses. So to overcome that, we have something of a concept that we call private and public IP addressing. So in this case, private networks are something which are protected or internal with respect to the internet, and we do not expect them to be accessible or to access the network, the internet directly. So given that they are not accessing the internet, or no one from the internet is accessing these private network hosts directly, they do not require publicly unique IP addresses from the internet. And this particular concept is what we call as public and private IP addressing. And to be very specific, there are three ranges defined for private IP addresses. The first one is from 10.0.0.0 to 10.255.255, 255.255 at these other two networks as well, 172.16 and 192.168. So these three ranges are to be used only for private networks. And the way the internet works is that it guarantees that these IP addresses in these three ranges will never be used as publicly accessible hosts on the internet, and they can be reused in any private network setup in any part of the internet, just given the fact that they are not accessed or they are not accessing the internet directly. So if we look at a comparison of public and private IP addressing, we can say that if anyone is setting up a host which is intended to access the internet, or we want this to be accessible from the internet, for example, setting up a web server. So we want the IP address of the web server to be accessible from the internet. So in those cases, we need to buy, lease these public IP addresses from ISPs, and only then be able to use the public IP address, and it is guaranteed that no other host on the internet will be using that particular IP. On the other hand, a private IP is where anyone who is setting up a private network can use any of the IP addresses in the private IP address range. So the way that these allocations are made, so given that public IP addresses are all unique, so anyone connected to the internet can access this IP address. So this is exposed to the public side of the internet, and it is guaranteed to be unique. And in most cases, the public facing interface or the internet facing interface on the default gateway must have a public IP, so that the private network can actually access the larger internet over the public IP address. On the other hand, for private IP addresses, computers outside the network cannot access any device with a private IP address, and any device with a private IP address must use the default gateway to be able to access the internet.